So 3.4 says if this expression is equals to p, write down this expression in terms of p. So here we have this expression and we are told that this is equal to p, and we have to try and express this other one in terms of p. So you could make this one look like that, or you could make this one look like that, and then you'd be able to find some sort of similarity. So starting with this one, what we can do is we can rewrite this 20k minus 1, taking this 2 and multiplying the power, which is 1 minus k. We realize this is the same as 2 to the power of 1, or multiplied by 2 to the power of minus k. And if we express that over here, we'd have 3 and then multiplied by 2 to the minus k is equal to p. But this can be just simplified with the 3 times 2. This is 6 multiplied by 2 if you want to represent multiplication by brackets to the power of minus k. This is equal to p. And we see that if I multiply both sides by 4, so multiply this by 4 and this by 4, then I have 20k minus 1. 4 will multiply this constant over here, since we are allowed to multiply numbers that are outside the sigma notation. 4 multiplied by 6 will give us 24, and add 2 and then minus k. This is equals to 4p, and we have expressed this like that, and we know that it is equals to 4p. That is one way to do it. The other way would be to try and create this expression out of this one at the bottom. So what we can do is break down the 24 into 4 times 3 times 2. So 4 times 3 is 12, times 2 is 24. So if I write it down as 4 outside the notation times 3 times 2, this will give us 24, and then have this alone as it is, and then we continue. This is 4, the sigma as it is, 3 times 2, that gives us 6, but we don't want to multiply this. We want to try and create this situation. So we've already created the 3, now we need the 2 to the power of 1 minus k. So what we do is we multiply this 2 and this 2 to the power of minus k. And I know I said earlier that you cannot multiply two numbers if one number has a power, but that's only under the condition that the bases are not the same. So if the bases are the same, in this case we add the powers. So 2 multiplied by 2 to the minus k will just give us 2 to the power of 1 minus k, like that. So this will give us 2 to the power of 1 minus k, and we can put the 2 in brackets, and we know that this expression is p. So our answer will be equal to 4p. Therefore, we express this in terms of p, and again we get the same answer. It will be equal to 4 times p.